So we're working in concert with Tiger to process material that's in Combie Reservoir, not on the plant, but stuff that's accumulating in the Combie Reservoir. And the purpose of this project is to remove that sediment, bring it up and treat it to remove the silts and the sands and aggregates from that material, and allow that material to be processed for the aggregate plant. In addition, because there's mercury in that material, we're removing the mercury as part of this process, which is the hardest part. The mercury, Carrie will explain the process here quickly, but what we've been doing is working on this project since about 2007 with the idea that if we need to remove sediment out of the reservoirs, not just Combie, but at Rawlins and a number of reservoirs that NID owns, because it naturally fills up with sediment. And by removing it, as we have done for 30, 40 years, it aggravates the mercury that's in there, and actually it's believed that that enhances the methylation process, which then becomes toxic to the biota. So part of this project is experimental. Part of it is removing the sand for the sand industry, for asphalt and concrete. And the other part of it is to clean our reservoirs and keep the storage water capacity available for storage water from year to year. Combie is not a storage reservoir. Combie is a diversion dam. It's not necessary to have a volume of water in Combie, but we're starting here at a small scale because when we move to Rawlins, which is a storage capacity reservoir, we'll have the science perfected. It's hard to do on a small scale, let alone a larger scale. So that's one of the reasons we've embarked on this process. We've invited you folks here because we wanted you to see this firsthand. We're also being reimbursed as part of a grant for some of these expenses to demonstrate by the Department of Water Resources. And so we're inviting you folks to come and see the process. We learn every time we do a demonstration like this, we learn more about it. In fact, we've learned quite a bit in the last few days. So, and that's an inside story. I'll let Carrie share that if she feels like. So with me is Dr. Carrie Monahan, who's been working with NID for 8 years on this project, and we've been working closely with Tiger Aggregates. Chico State is part of the process, and mostly importantly, the Sierra Fund is our partner in this process. That we've embarked on the mission of removing mercury from the environment, and as you know, we have a selfish reason, because we have to remove the sediment out of the reservoir. We have a mutual goal, both with the environmental groups as well as the water industry. And it just so happens that the sediment has a lot of sand in it that is used for construction industry. So this project has become more of a meld of environmental science, environmental benefits, water storage capacity restoration, and especially in a time of a drought, and sand and the mining industry as well. Anything else I missed out? There's a number of other benefits downstream that we'll go into. Yes, sir.
Can you point out where on your map to your right there, where that sample came from?
Yeah,
Sure.
I'll start this. Hi everyone, it's really exciting to have you here, and I think the reason I like explaining the process so much is that I'm really excited to understand it. I've been involved in, still excited to understand it. I'm an environmental scientist, I'm a hydrologist, I work at Chico State, and I'm the science director for the Sierra Fund, and Izzy Martin is here with us today as well. So very excited to be a part of this process from the beginning, and I've seen it go from kind of a phase 1 to a phase 2 to a phase 3, and this is the first time we've been on the actual project site itself, and so this is the most how it's going to look when we go to operation than it ever has been before. So in some ways it's easier to explain, because that sample, sir, did come from the actual project site, which is where the sediment has accumulated in the upper portions of Combie Reservoir. It was excavated. It was excavated because it's so dry right now, and we have low water almost everywhere with earth-moving equipment. In the future, when we actually go to operational scale, we'll have a floating electric dredge out there, and that's that other picture over there. We have not reached that stage of the project yet. We're still perfecting our sediment and water treatment processes for the slurry that we create by treating this material. So I think Tim explained the multiple benefits really well, but you can very clearly see the amount of sediment that's accumulated in the upper reservoir. And so by restoring that water storage space, we help make it possible to better operate Combie Reservoir. Tim also really well explained that this is still a small scale, and we'll go to water supply reservoir next up at Rollins, where a lot of sediment has accumulated down Greenhorn and Steep Hollow Creek. And NID has to be able to maintain their water supply facilities. So we're still early in the process, but we're farther along than we ever have been before. So that material was excavated from the reservoir. It was put in a big pile of dirt out here. You can see one kind of near the by the machine here, and then there's some other piles over there. So we're processing in batches, and we have a series of samples that are taken with every batch because we're still trying to understand how well each step works, and of course meet all water quality requirements that we've been given with our 401 certification that the Water Board has issued us here. So essentially you saw the claw here on the backhoe scooping up a slurry that's meant to represent what might otherwise be coming in along a dredge line slurry. Probably 50% solids, 50% water. It goes into this shaker table where the larger stuff is screened off. It moves down that where the water is put in a pipe. You can actually see the pipe underneath the bottommost table there. And that slurry is then brought over to this trailer mounted unit. And on the trailer mounted unit, it first goes through a SWACO screening step and then into the Nelson concentrator. It's a modified Nelson concentrator. It spins, it's a centrifuge. It spins at 60 to 80 Gs, very fast. It has reverse drilled holes in it and an outer water jacket. So anything of specific gravity 3 or greater, like gold and mercury, spin to the outer edges of that cone into the threads there and out into the outer water jacket, where it is shunted off into an accumulator box. And I'm very glad that Will is here from Oro Industries because he's helping us perfect that polishing step for what is accumulated. And that's how we'll be able to answer how much gold and how much mercury, liquid, elemental mercury, we get from treating the sediment. So I specify the type of mercury because there's many different forms, and what we've seen is that from previous tests, this seems to remove about 93% of the liquid elemental mercury. However, there's other metals, and mercury being one of them, still bound to the silts and clay particles that are still in suspension here. And that's the dirty water you see in this green tank. This is a wheel wash. This dirty water has to go through a water treatment step. So if you will, this is a sediment treatment step, and then this is a water treatment step. And so this suspension of slurry material goes into a series of pipes that you can see on the ground here underneath the blue tank, where 2 different polymers are added. One is a charge, the P50, and the other is a coagulant, a P665. My graduate student from Chico State, Nick Graham, is here. He's been helping us perfect the ratios of those polymers. He did bench scale tests, and now we're trying to bring it up to field scale, and you can all appreciate how challenging that is. And that's why we're doing so many replicate closed system tests to be able to see how well it works. That's his master's thesis. It better be well done, right? And so then we have this slurry of water, which actually you might see on a pipe running right through this tent if we hadn't buried it in a culvert, because it comes out right there where that orange T-post is, and over into the first settling tank. There's 2 settling tanks in series. The first one has a series of baffles, and it fills up and allows all of those heavy particles to settle out now that they've been coagulated, if that's a verb. They settle out, and we have clearer and clearer water with every baffle that water is flowing over, and then it goes through a second clarification tank. We've been testing at both of these tanks, and we've been testing at this wheel wash step. We've been testing the water that comes in that we're using from the river. But the most critical step is the test site, the sample site at the end of that second tank. Because hopefully by tomorrow we will have processed enough material to have both of those tanks completely full, and that sample has to meet water quality requirements before it is released to the reservoir. NID did an anti-degradation study to help inform what those water quality requirements were, and then the Water Board has given us a 401 certification to tell us what we had to meet before any of that was released. So we're operating like a water treatment plant, which NID has plenty of and is quite good at understanding and permitting. That's a benefit. But we're also operating a little bit like a mining system here too, which is new for the district. And so we're all learning step by step. Do we have questions? Yes, sir.
So if you don't meet the water quality requirements at the end, then
We stop. We stop completely, and we have to discharge that water to land somewhere else. We may truck it off. That's why I'm so excited and nervous at the same time to be on site. Because when we were testing the equipment before, we were out in the equipment yard up on Tygert's property, and we had a really large detention basin there where we could discharge to land. So that's the answer to your question, is that we need a discharge to land option out of the 100-year floodplain. Yes, sir.
Are the tanks you refer to those blue things?
Yes, sir. Yes, they are. Those large storage tanks.
Are you the principal investigator for this grant?
What am I? I'm a scientist. I'm a research scientist. I guess.
Are you a recipient of some of this grant money?
Yes. Well, yes, absolutely. And yeah, and NID is paying for all of the lab samples that are here, and they've also hired the Sierra Fund to do the outreach component. None of you would be here without outreach. So the Sierra Fund answers and responds to emails, which sometimes is difficult for Mr. Pro to get to with his extremely busy schedule. Nudge, nudge. So basically, we've helped raise awareness about this project. But yes, I've been a part of testing this equipment since 2009. I'm very glad to be.
Are you actually a part of NID then?
No, sir.
You're a contractor.
Correct.
Yeah.
I am the science director at the Sierra Fund, and I'm also adjunct professor at Chico State. So I am those two things at least, and we are contracted by the Sierra Fund. I'm also a mom and a sister and other things. Yes.
do you do any assays on the material before it goes into the system so you know what the gold and mercury content is?
Yes, we have done that, and I would like to say we've tried that. Because when you talk to miners, when they talk about a sample, they talk about a sample the size of this tent. And when you talk to environmental scientists and they talk about a sample, they talk about, 250 milliliters of water. And so we have not done the large batch scale sampling that the mining industry would probably have done first. We've done the smaller scale tests, and we've tried to do replicate random samples of the stockpile to represent it, but literally the material suffers from what we call the nugget effect. In other words, it's not a homogeneous material whatsoever, so it's very hard to get a replicate sample.
So did you take a sample out of that pit today?
Not today, no. We've sampled this material previously, and we took 10 to 20 samples when we sampled it.
Can you tell us where you're taking samples through this whole flow sheet?
Yes, absolutely. So this first sample that we take is at the river here, or the pond. So that's the water that's coming in. I have an in and out conceptual model going on here. So what is the background, right? What are we using in the equipment? Very, very important. The second sample we take is what's coming out of the Nelson concentrator here. This very slurry, this muddy, the muddiest water that you have, right?
Just the water?
Correct, just the water.
So nothing from that black tank, or is that black tank all product?
That's generator right there?
No, the one right here with the green and the white hose going into
That
it?
black tank is holding 2 5-gallon buckets of discharge. One is this is what we're going to call the concentrate. And I just pulled this out to show it to you. We're going to process this over here.
We previously did.
So when the concentrate is formed in the Nelson concentrator, we turn off the machine and dumps the waste in that cone to this bucket. And that's our concentrate that'll have the gold and the mercury in it. Plus there's some accumulators on that that'll collect gold and mercury as well. But we're mostly interested in this material because it's heavy ore material. And we'll take that and process that in a bit. But the other hose, the green hose, is coming off of a magnetic wheel which is picking up magnetite. And so that's dropping out in another 5-gallon bucket. The purpose of the force trough really
It's
is
not mixed in there, but you have
to
two
keep it
separate
from,
samples.
yeah, because it's got to be the water flowing through it all the time. So we got a little pump that's the little green garden hose pumping over to here, just the excess water. So